Recording in progress.
Good afternoon to all distinguished guests. Assalamualaikum warahmatullahi wabarakatuh. Sawadika, pardon me if my pronunciation is not correct, Dr. Tanavich. It is my great pleasure to welcome you all to today's guest lecture, organized by the Faculty of Farmasi, Universitas Jember, held virtually using Zoom meeting platform. We are truly honored to have your presence in this academic session entitled An Environmental Pharmacoepidemiology Approach. My name is Yunita Diah Kusumaningrum, and it is my privilege to serve as your Mistress of Ceremonies, also the moderator for this afternoon event. Before we begin, allow me to extend our warm welcome and respect to everyone joining this special occasion. First of all, we would like to welcome our Honorable Dean, the Faculty of Farmasi Universitas Jember, Professor Ari Satyanugraha, PhD, and our Honorable Vice Deans. We would also like to warmly welcome all lecturers from the Faculty of Farmasi who are joining us today. We would also like to warmly welcome to all of our students from the undergraduate program, the pharmacist professional program, and the master's program who are participating in this guest lecture. And of course, our deep appreciation and warmth welcome to our distinguished guest speaker, Dr. Tanavich Panoy, B.Pharm, BBA, MPH, PhD from the School of Pharmacy, Walayalak University, Thailand. Thank you, Dr. Tanavich, for your kind willingness to share your time, experience, and expertise with us today. The session today will run from 1 to 3 p.m., starting with an opening remark from our dean, followed by the guest lecture session delivered by Dr. Tanavic. Afterwards, we will continue with Q&A discussion session, and finally, we'll conclude with a short closing. To officially commence today's session, we are deeply honored to invite Professor Ari Satyanugraha, PhD, Dean of the Faculty of Farmasi Universitas Jember, to deliver the opening remarks. Professor Ari, the time is yours.
Okay. Thanks. Okay. On behalf of the faculty, I do appreciate for your time, Dr. Tanavic Panoi. I think hopefully the time difference is suitable to you too. Like we are in here about 1 p.m. We're not sure over there, but this is part of our ongoing. I mean, we're approaching to have an MOU in the early next year. So really like to thanks to you that we already start this with this engagement with the lecturer today. So I really appreciate your time to give a lecture to still for our students, because our students part of the Southeast Asia communities. So we like to have like your expertise sharing about the pharmacoepidemiology to our student. This is really good for us because we have a good understanding that the what's called the pharmacy practice in Thailand is quite well established, I think, compared to here. So we like to have, I mean, the share from the experience from the Thai partners. So we have here students. I think year three, year three, right? 15, yeah. Yeah, so this is really good for us. And then early next year, we will sign out the, hopefully, in the early next year, we sign the MOU, and then we start the student exchange too for the undergraduate. And then we like to have a possibility for sending internship student for the pharmaceutical degree. So this will be have like a strong bonds between us. We already checked the university, Walayak University. It's really green campus, so we are inspired that this is good. Yeah, and then hopefully you can enjoy and then share your expertise to our student, our academics in here, and hopefully we can have a meeting in person in the future. So thank you very much for your time, and then I send the time back to the moderator, the ceremony. Okay, thanks.
Thank you very much, Professor, for the opening remark. Now we are moving to the highlights of today's session, the guest lecture entitled An Environmental Pharmacoepidemiology Approach. As we begin this lecture session, we would like to sincerely thank Dr. Tanavic Vanoy for kindly accepting our invitation and taking the time to share his valuable insights with us today. To lead the session and discussion, please allow me, as the moderator, for this session, I am delighted to introduce our guest lecturer, Dr. Tanavic Panoy, B.Pharm, BBA, MPH, PhD, a lecturer from the School of Pharmacy, Walayalak University, Thailand. Here's the curriculum vitae from Dr. Tanavic. Dr. Tanavic Panoy, B.Pharm, BBA, MPH, PhD, is a lecturer at the Division of Pharmaceutical Care, School of Pharmacy, Walayalak University, Thailand. Dr. Tanavic completed his Doctor of Philosophy in International Health from National Yang Ming Chiao Tung University in Taiwan in 2023. He also holds a Master of Public Health from Chulalongkorn University, a Bachelor of Business Administration in Marketing from Sukhothai Thammathirat Open University, and a Bachelor of Pharmacy from Prince of Songkla University, Thailand. Recently, he also completed a certificate in pharmacogenomics and precision medicine from the College of Pharmacogenomics and Precision Pharmacy, Thai Farmasi Council in 2025. At Walailak University, Dr. Tanafij teach course in Social and Administrative Pharmacy, Health System and Pharmacy, Research Methodology, Pharmacoepidemiology, Pharmacoeconomics, Drug Utilization Research, and Healthcare Policy and Financings. Dr. Tanafij has contributed to a number of national and international research projects, including work on primary care pharmacy service development in Thailand, health system financing assessment in collaboration with the Thai Ministry of Public Health and the World Health Organization, and studies on chronic kidney disease and drug safety. He has also published widely in peer-reviewed journals such as the Journal of Public Health Policy, International Journal of Nephrology and Renovascular Disease, and the Thai Journal of Pharmaceutical Science. Among his recognition, Dr. Tanafij received the Best Presenter Award for excellent quality of content and presentation at the Asia Pacific Health Promotion Capacity Building Workshop in Taipei, Taiwan, 2020. Today, he will share his expertise through his lecture entitled An Environmental Pharmacoepidemiology Approach, where he will discuss how environmental and climatic factors influence medication use and health outcomes. Without further ado, please welcome Dr. Tanafij Panoy to deliver his presentation. Dr. Tanafij, the screen time is yours.
Thank you very much, Dr. Unita, and thank you for a very great introduction. To be honest, I'm quite surprised when you pronounce the Thai word. You pronounce very clear and very well, Dr. Unita. And thank you for the Dean for the open remarks statement. And I hope this would be an initiation between our collaboration in terms of the academic research and for anything in the future. Thank you very much. And with no further ado, I want to share my slide, and then it will be a session of the lecture. Please wait a moment. Now you see my slide?
Yes, we can see it clearly, Doctor.
Okay. Okay. Let's start with the session today. And to be honest, I'm very excited to present this topic because it's quite new. This topic is very new, even in terms of the pharmacoepidemiology. There are a few researchers who are interested in this topic in the global platform. So I would like to say that please be aware that the results from the study in my slide are the part of unpublished manuscript on the day of this presentation. So I strongly do not recommend to use as the official reference, but you can learn, and if you have some discussions or do you have some comments during this due to this topic, feel free to share your opinions, and maybe we will have a discussion during the Q&A session. Let's start with the background. In many decades ago, when we think about the medication, we always think about medication in many aspects, like a safety, efficacy, effectiveness. But since the time goes by, and during this time we encounter with the global climate change, we will know that medications and medical devices interact with the global and local environments. For example, during the climate change and disaster, you might see that it affects to the drug use for the people. During the disaster, people tend to people tend not to access to the medication. That would be the barrier. Can you mute the microphone? Okay, thank you. That can be happened. During the climate change and disaster, people will, I mean, in terms of the patients will not be able to access to the drug. So you might see that climate change and disaster affect to the drug use and increase the adverse events. We haven't met any new adverse events since the climate change has come. And in terms of the local environment, constrained drug distribution and the utilization, and you will know that there are many diseases came during the climate change, for example, and those kind of the disease would be so-called a new comorbidity. So there are some interaction between comorbidities and environmental factors, and then it will trigger to the higher harm risk among the people's health. The challenges in terms of the pharmacoepidemiology, if you study about the pharmacoepidemiology, people will know that first, measuring the drug exposure is very complex. If you think about epidemiology, we are interested in two terms, something about the exposure and outcome. But the drug exposure is very complex by itself. For example, people tend not to follow the adherence of the drug well. Some people adhere to the drug, but some people may not. Unlike also exposure in epidemiology. So we know that measuring drug exposure is very sophisticated. However, even measuring environmental exposure is even more complicated because people are movable. The locations of people are not certain. So it's really difficult to measure how much that people expose, how much doses of the environmental factor that people will expose to. So we all know that measuring environmental exposure is even more complex. But the thing is even more complicated if we want to integrate these approaches together. So I mean that in terms of the environmental pharmacoepidemiology, we are interested in the interaction or two exposure. The first one is the drug exposure, and the second one is the environmental exposure. So these two exposure by themselves are very complicated, but the thing seems to be really complicated when we want to study both together. The rationale of environmental pharmacoepidemiology, you know that current pharmacoepidemiology rarely integrate environmental factors. We see there are only a linkage between drug and the health outcome. But missing environmental context of medication use and safety might be a drawback when we want to assess about the causal inference between the exposure and the health outcome. So for the environmental epidemiology, which is the main theme of the environmental pharmacoepidemiology, I just want to define the terms of the environmental epidemiology first, and then we'll let you know what kinds of the definition of the environmental pharmacoepidemiology. Environmental epidemiology is a branch of epidemiology that studies how environmental exposure such as air pollution, water contamination, chemicals, radiation, noise, and climate factors affect the distribution and the determinants of health and disease in population. In short, I would say that environmental epidemiology, we are interested in environmental factors and the outcome. The outcome that we are interested is something about the disease in the population, something about the distribution and the determinants of health. But in terms of the environmental pharmacoepidemiology, in terms of the environmental pharmacoepidemiology, we are interested in the study how environmental factors and medical products interact to affect the medical utilization and the health outcome. You might see definition. We are not only interested in medical product or medicine, but we also interested in the interaction between environmental factors and the medical product to affect the medication utilization and the health outcome. We combine the principles of the environmental epidemiology and pharmacoepidemiology together. But rather than to focus on isolated effect or independent effects between environmental factor or medical products, we are interested when environmental factor interact medicine or the drug or medical product, how much they affect to the medication utilization and the health outcome. Therefore, in this slide, I underline that in terms of environmental pharmacoepidemiology, we focus on interactions or synergism, not isolated effects. In case of the interaction in epidemiology, it is never be easy. So I just want to take a few minutes to introduce all of you what kinds of the interaction that we usually see in epidemiology. Okay, this is a very simple example that I will show to explain what kinds of the interaction. In epidemiology, we have two types of the interaction. The first one we call multiplicative scale. The second one we call additive scale. For example, in this case, if you do not expose to drug A or drug B, the risk that you will become disease, it will only 0.05 or 5%. Okay, but whenever you export or you take the drug A, the risk will be increased to 15% or 0.15. Likewise, when you only take drug B, the risk will be 15. In this study, for example, this is a study where if you take both medication, I mean both drug A and drug B, the risk will increase to 30%, which is 0.30. This is the observed risk that you found from the study, supposedly. Okay. In case of the multiplicative scale, if you want to find relative risk of taking drug A only, the relative risk will be 0.15 divided by 0.05. it shows 3, right? But if you see only, but if you see relative risk of the drug B only, it will be 0.15 divided by 0.05. It means 3. In case of the multiplicative law, if we are expected, or we assume that if you take both drug A and drug B, the relative risk under multiplicative law will be 3 multiplied by 3 equal to 9. This is what we expected to see when we take both drug A and drug B. However, in this study, you will see that the observed relative risk when you consume drug A and drug B is only 6. So that means the observed relative risk is lower than the expected relative risk. We call in this case as a negative multiplicative interaction. We see something so-called interaction, but the interaction that we observe is lower than we expected. So we call it negative. But still, there is something so-called multiplicative interaction. Okay, this is if you think the interaction in the multiplicative scale. Another type of the interaction we call additive scale. In additive scale, I use the same example. If you think, okay, if you take drug A and drug B, we expected that the jointed risk, or the risk that you will become a disease, if no interaction, should be 0.15 plus 0.15, but no interaction. So we minus the 0.05, it shows 0.35. This is what we expected for the risk that you take drug A and drug B if there is no interaction. However, for the observed risk that you see in reality, when you take drug A and drug B, the risk will be 0.30, not 0.35. So that means there is something so-called relative excess risk due to the interaction around 0.05. We call this number as the positive additive interaction. So it depends on your study when you look into the interaction. Some study will provide you in multiplicative scale. For example, if you study something that result about the relative risk, the hazard ratio, the odds ratio, that's kind of the study will try to show you if there are some interaction result in that kind of study we call multiplicative scale interaction. But in terms of the additive scale, for example, some study will report the result like a risk difference. So if there is something so-called interaction in the study result risk difference, we call that interaction is measured by the additive scale or by additive law. So that's two kinds of the interaction. You might see that it's quite a little bit complicated to understand, but it's really necessary to explain before I jump to the example of the study that I will show you today. There is a study that I think would be a pioneer of the study in terms of the environmental pharmacoepidemiology. It's done by the Professor Soko Setoguchi from University of Rutgers and the Harvard University member Professor Kevin Joshi. So in this study, rather than just study only the association between corticosteroid exposure and cardiovascular events and thromboembolic event in older adults, you might know that in principle, in terms of the pharmacotherapy, yes, we discover the association between people who consume or take corticosteroid and cardiovascular disease or cardiovascular events. However, in this study, they try to be more a little bit investigating in terms of the synergism between air pollution and corticosteroid exposure in promoting or in increasing the chance to become cardiovascular or thromboembolic events among the older adults. In this study, you might see that if we report in terms of the hazard ratio, the x-axis we show the multiple outcomes that we are interested in this study. For example, if you want to see the association between using corticosteroid only and the outcomes that we are interested, you might see that it seems that there are a high hazard ratio for people who consume corticosteroid and will become atrial fibrillation, for example, heart failure, myocardial infarction, etc. But if we look into the isolated effects of the PM2.5, in terms of the standard PM2.5, in United States, we call the standard PM2.5, which is still safe for people, is around 10 microgram. Okay. In terms of the people who live or who exposed to PM2.5, 10 microgram compared to 5 microgram, you might see that the hazard ratio of people who exposed to the 10 microgram has more likelihood to become, for example, venous thromboembolism, myocardial infarction, or even the heart failure. But in these two panels, we look into isolated effect. One for the corticosteroid use and one for the PM2.5. What if we look into the combination effect between corticosteroid and the PM2.5 to make more reality in terms of the understanding? For example, what if people inhale corticosteroid and still living in the place with the PM2.5 around 10 microgram? This kind of the combination effects or interaction effect can lead to the heart failure, atrial fibrillation, or even venous thromboembolism. We see that after we combine the effect between these two exposure, the hazard ratio tend to be decreased, but still it still shows something so-called multiplicative interaction. But the multiplicative interaction in this interaction, it seems to be negative, which means it's lower than we expected. So you might see the all outcomes show the hazard ratio lower than the hazard ratio when we look into isolated effect. But if we look into the additive interaction, as I mentioned, it's quite interesting when we look into this graph. When we see this graph, people who stay in the place with PM 2.5 less than 10 milligram and inhale corticosteroid or use corticosteroid tend to become the cardiovascular events like it show in the slope of each graph for each outcome. This is we call the positive additive interaction in the study. So in case of you don't understand what kinds of the multiplicative, what kind of the interactive interaction, in brief, I just want to say this study introduce you to know that there is something so-called interaction between the drugs that you use and the pollution factor, so-called the PM 2.5. The interaction between drugs that you use in this case is the corticosteroid and the PM 2.5 in the place that you live. When they interact each other, it's linkage. There is some linkage between the interaction between PM 2.5 and corticosteroid to the health outcome, which means cardiovascular event in this report. I would say this is the first study that shows the interaction about the drugs that we take and the environmental factor that we also live in the same time. But in my study, I have lower ambitious than the previous study, because in my study I just want to see there is something so-called the macrolide use pattern, like a seasonal use pattern in macrolide, and I just want to know that is there anything so-called the interaction between the temperature and the humidity interaction that affects to the pattern of the macrolide use? In my study, which is under review by the journal, I don't link my study to the health outcome, unlike the previous study that I tried to show you, because there are some scarcity of the data that I use. So in my study, when I try to explore something about environmental pharmacoepidemiology, I try to explore first, is there something so-called seasonal use of the macrolide in my study hospital setting? The second, is there something so-called temperature humidity interaction which affects whether or not affect to the macrolide use in my study hospital? So I don't jump to any health outcome in my study. So this is what we say, and that's the reason I say I have lower ambitious than the previous study in terms of the result. Okay, in my study, the rationale is, I think that the climate factors like temperature, humidity, and rainfall, we all know that the temperature, humidity, the rainfall affects to the disease incidence. For example, in the low temperature and the high humidity, people tend to be suffer with the respiratory infectious disease, right? And in terms of the people who stay in the very high ambient temperature and high humidity, they tend to suffer with the gastrointestinal infectious disease. So that means that we all know that there is some link between climate factors and the disease incident. Okay, from disease incident, if we know that, okay, if there is some link between climate factor to the disease incident, finally the disease incident will link to the antibiotic consumption or antibiotic demands. For example, if you during the low temperature but high humid, people tend to be more suffering with the respiratory infectious disease. After they suffer with the respiratory infectious disease, that means there are increase of the macrolide prescription. So this is my assumption. This is my assumption during on the basis of the principle that we know about the general epidemiology. And regarding to climate factor linked to the disease incident, there should be something so-called seasonal variation in terms of the antibiotic use. And there might be some strong effects in tropical and subtropical region, because the Tasala or the Sadi Hospital, which is the university hospital, it is located in a very tropical area in the south of Thailand. So regarding to this assumption, I would say there might show something stronger effects in terms of the antibiotic demand in my area. That's the reason I try to find something in relation between climate factor and the antibiotic demand. Having stated that, some studies have explored the relationship between climatic factors and the medication, including antimicrobial use. For instance, in UK, a study reported that lower ambient temperature were associated with a lower number of antibiotics used. However, in a Spanish study, it reported a positive association between cause-specific medical prescription and daily mean temperature. But this kind of the association is not in the linear trend, but it shows with non-linear trend, like a inverted J or the V-shaped relationship. So that means what we discover from this literature review. The first one, lower ambient temperature. There is some association between temperature and the number of the antibiotics used by the UK study. The second one, whenever people use the medication or medical prescription, the association between the temperature and the number of the prescription is not in the linear trend. It is in the non-linear trend. So that's after I make this study review, it links to my study that it links to my rationale of the study that in my study area, macrolide antibiotics are commonly prescribed for respiratory and also infections, with usage often influenced by seasonal and environmental factors. However, evidence on how temperature and precipitation affect antibiotic consumption in tropical setting remain limited. So in my study, the objective was to explore the association between climatic factors, which are temperature, rainfall, and humidity, and the use of the macrolide in the south of Thailand. The study design that I used the retrospective longitudinal observational study was to examine the association between the climatic factors and the macrolide prescription. Between January 2021 and December 2023. And the study was designed to evaluate temporal and environmental determinants of antibiotics use by modeling antibiotic consumption data at my UT hospital. I use the prescription record and link the prescription record to the climate data used in insurance registration area to assess regional environmental exposures. The study population comprised any patients who come to the hospital and receive any prescription with antibiotics during the outpatient or inpatient visit in Valley University Hospital. For environmental factor, you might be curious, oh, how we measure the environmental exposure in this case. First, I use the daily climate variables were obtained from two authoritative remote sensing sources, which is so-called the Google Cloud Public Dataset and the NASA prediction of worldwide energy resources. These are open and public data source for the climate data. For example, if you want to know that, okay, in this year, in today, people who stay in my area, they actually exposed to how much degrees Celsius of the temperature, and including the percent of the humid in the air. So in these two open data sources can provide you the environment, the climate variables that we want to use. These data were averaged to bi-weekly interval, not daily interval, because we believe that people who expose the environmental factor, they should export environmental factor in some certain time, not instant time. So I made an assumption that after they expose to the bi-weekly, for example, bi-weekly ambient temperature, whether or not it affects to their health outcome. So that's the reason I use the bi-weekly interval and geographical link to the patient's insurance registration, serving as a proxy for their residential location. For environmental factors, the primary environmental exposure of interest was bi-weekly average temperature. However, rainfall or precipitation and the mean humidity were also included into the model for broader meteorological influences. And lagged temperature values were generated for 4 prior bi-weekly periods to evaluate there is delay effects on prescribing behavior. And the model that I use in this study, I use something so-called generalized additive model, so-called GAM. So who are not who dislike or who feel awkward when you look into the statistical equation or some jargons. I just want to make it more simple. If you remember, I told you that the association between temperature or the climate factor and the prescription and the number of prescription is never be in the linear trend. Therefore, we cannot use generalized linear model in my study. The thing that we try to add in my model, we try to add something so-called non-linear terms, especially the non-linear terms of the temperature, humidity, and the rainfall. So in GAM or generalized additive model allow us to add nonlinear term in the model. That's the reason I use the GAM rather than the GLM in this study. Key message from the GAM. GAM is the GLM, but it allow us to add nonlinear term into the model. So after we add nonlinear term into the model, it can capture nonlinear effects, especially from between the temperature and the pattern of the macrolide use. So when we use the GAM based on the basis of a smooth function, it's flexible and more interpretable. Okay, to assess the relationship between environmental factors and macrolide consumption, as I mentioned, we use the GAM in my model. But the thing that I am interested as in terms of the environmental pharmacoepidemiology, you remember that we are not interested in isolated effects. I mean, we are not interested in isolated effect from temperature or isolated effect from the humidity. But the thing that I'm interested is the interaction between biweekly average temperature and biweekly humidity. So in this case, I put the interaction into the model, and I believe that the association between this interaction term and the macrolide use or macrolide consumption has never been linear trend. So I believe that it should be non-linear trend. That's the reason I use the smooth function in this statistical model to make sure that it can be flexible and interpretable when we come up to the result. To see how temperature changes affect macrolide use, as I mentioned, instead of assuming the relationship is a linear trend, we let it curve naturally so it can show more realistic pattern. To guide the shape of that curve, we place reference points, so-called knots, at temperature that represent 25, 50, and 75th percentiles of all temperature recorded. It's something like a statistical technique, so you can skip it. You can skip this part. And we also look at whether or not temperature has an effect right away, or only after some time, like 2, 4, 6, or 8 weeks later. To do this, we model the delay in effect, so-called the lag, up to 8 weeks. We again use a smooth curve to let the effect change flexibly over the time, and we place more detail at the earlier time periods, where changes usually happen faster using logarithmic spacing of knot. This is something so-called the statistical technique. You can skip this part. But the thing that I also add into my model, I just want to know what kinds of the temperature effect in isolated effect as well. But the thing that I'm interested is whether or not temperature has an instant effect, or it show delay effect after 2, 4, 6, or 8 weeks later, to the effect to what? Effect to the pattern of the macrolide use. So Previously, I make a summarize of the statistical and the study design that I use. So let's see the result that came from my study. First of all, I just want you to look into this see the temperature pattern in in my area, especially Tasala City. Walayalak University Hospital and Walayalak University, we are located in Tasala district. Tasala district is in the Nakhon Si Thammarat province, which is the south, which is located in the south of Thailand. And you might see that Tasala during December, January, and February, the temperatures seems to be around 25.8 or around 26, but it's a little bit higher during the summer months, which start from March, April, and May. The average biweekly temperature increased a little bit from 26 to 27, but in average the temperature the annual the annual average temperature across the year in Tasala City is around 26 to 28 as the maximum. I mean, in terms of the bi-weekly temperature. But if you look the temperature during the years that I studied, which were 2021, 2022, and 2023, it seems that especially in summer, the temperature has increased across these 3 years from 2021 2000 until 2023. And during the winter, if I would say in Thailand, we don't have something so-called winter. But this is something that I when I use the R and when simulation, they call the months that comes up with the lower temperature as the winter. But actually in Thailand, we don't have the winter. We have only 2 seasons, especially in the south of Thailand. We have only rainy season, summer, and a very, very summer in my area. But during the month which come up with the lowest temperature across the year, it seems that from 2021 to 2023, the temperature has increased significantly across these 3 years. And I would say this is a kind of the effects from the climate change. So when we look into the nature of the temperature across these 3 years, you might imagine you might be curious what kinds of the macrolide pattern across these 3 years. Is it the same pattern, or are there something are there some typical trend across these 3 years when there was something so-called the climate change between 2021 to 2023? And this is a rainfall pattern, and I would say Tasala is located in the monsoon area. So during the rainy season, we also encounter with the high level of the rain during the rainy season. And for the humidity, it will be relevant to to the rainfall pattern. Now we jump to the macrolide pattern. When you know the nature of the climate factors in the study hospital where the prescription occur in my study. So what happened to the macrolide pattern used across the year? If you remember the first research question, I asked myself that, is there something so-called seasonal macrolide consumption in my study in the university hospital or not? I would jump to this result. You might see that across the year there is an increased trend of the use of the macrolide from January until December, and it may decrease during the January and the February, which is so-called the winter season. And after winter season, it will become increased across the latter of the month in the year. This confirms that for the pattern of the macrolide use, it shows seasonal effects for the macrolide use in my university hospital. Again, confirmed by the total DDD across the month, it seems that there was the highest number of the DDD of the DDD stand for defined daily dose. There is the highest number of the macrolide prescription across since August until December, and the trend has been decreased from the January to the March, and since March the trend has been increased. Increased during the summer season and increased during the rainy season. When we try to portray a little bit what kinds of the interaction, which is the second objective of my study, is there any interaction between temperature and the humidity? In this graph, it shows significantly interaction between temperature and the humidity. In average, around 28 Celsius degree with 86% humidity, it yield with the highest number of the macrolide prescription. Therefore, from this graph, you will see that, oh, in this point, there is some interaction between humidity and the ambient temperature, especially during the highest temperature and the highest humidity. People or patients tend to be given by the macrolide in my study hospital. And if you look into the isolated effects for the rainfall, comparing to for the rainfall, it seems that when it shows something interesting. People tend to be less given by the macrolide when the rainfall quintile has been increased. What does this mean by that? When it seems that comparing to the day of the heavy rain and the day of the non-heavy rain, it seems that the day of the heavy rain, people tend not to be given by the macrolide, comparing to the day that which is not the heavy rain. So in terms of the explanation, people tend to go to the hospital less during the rainy season. So we assume that this is the explanation for this result that you see in this slide. And I mentioned we want to see the effects of the lack temperature. In this graph, it seems that warmer temperature are linked to the steady increase in the macrolide use in both immediately and up to 8 weeks later. In contrast, cooler temperature may cause a short-term increase, but are followed by reduction in antibiotic use after a few weeks. But mid-range temperature show little to no effect. So what does this mean by this slide? It seems that in warmer temperature, there is the lag effect there is the lag effect of the temperature 8 weeks that link to the steady increase of the macrolide use. However, when the temperature has been dropped swiftly, it may cause a short-term increase in macrolide consumption. However, in the week later after that, it showed a reduction in macrolide use after the few weeks during the winter season. So when you look into the result, which is quite strange and maybe it look weird for some of you in this case, but I try to explain or discuss the thing happened from the result. As I mentioned, the first research question I want to see, is there any seasonal use of the macrolide in my study hospital? The results show that macrolide prescribing steadily increased throughout a latter part of each year, reflecting broader seasonal antibiotic prescribing trends in respiratory infection, especially used for adults who were community-acquired pneumonia with comorbidities, including chronic heart, lung, liver, or renal disease, or diabetes mellitus. And people who with this comorbidity were higher at risk of atypical pathogen. That's the result lead people to receive more macrolide in my study. So you might see, as I mentioned, because the most people in my study are adults, so they come to the hospital not just only the respiratory infection, but they are also have their own comorbidity, which may trigger the severity of the symptom. That's the reason those people had to be given by the macrolide, especially during the summer and the rainy season. Patients with this comorbidity were at risk of the atypical pathogen, which is the rationality reason to prescribe the macrolide among the respiratory infectious patient. The potential reason for macrolide use in warm and humid condition, if you remember the interaction between humidity and the temperature at 28 Celsius degree and the 87% humidity, The potential reason for this may be as a result of the seasonal respiratory syncytial viral or RSV infection from summer to rainy season, along with the rise of the macrolide use as a drug of choice in treating RSV from April to the December. I would say in university hospital during April to the December, RSV is a common respiratory infection that we usually see, especially across the 3 years from our students and our patients who came from outside the university, who came from outside the university, but they use the service at the university hospital. It seems that RSV is a common respiratory infection, and it's spread and is epidemic from April until the December. This is the reason that you see why macrolide has been highly used during the warm and the humid condition in, strictly speaking, in my study hospital. However, there are some limitations due to my study. The first, this study so-called ecological design. Ecological design actually limited causal inference. While the temporal association can be easily confounded by other covariates that are seasonal, such as duration of antibiotics and pollution levels, you might see that in environmental factor, I didn't add pollution level like the PM 2.5 or any pollution substance into the model. So this so-called unmeasured confounder, which may affect to the causal inference in this study. Again, in this study, the absence of microbiological data, which is so-called, for example, antimicrobial resistant data, restrict the linkage between prescribing pattern and specific pathogen burden. That's the reason I try not to link between the prescribing pattern and the cost of the prescription, or the reason why people receive the macrolide, because we lack of the microbiological data in this study. Moreover, we may have had selection bias since the prescription data was collected within Walayalak University Hospital, and the data may not be reflective of the Southern Thai region. Regarding inclusion criteria of prescription patients aged over 19 years, the seasonal use of this antibiotic in children could have different patterns as compared to adults. In this study, we use only people who age 19 or more, who age 19 years or more. So people who were children, they might show different pattern of the macrolide use comparing to the adults. Future research should integrate antibiotic utilization with diagnostic and resistant data, ideally across multiple Thai hospitals, to assess the generalizability of these findings and clarify underlying mechanism. So, you might, from the first slide until to this slide, you might curious, or some of you might be curious, what kinds of the benefits that pharmacists can gain from the knowledge when we try to combine environmental factors into the medication use and see the interaction between environmental factors and medication use to the health outcome. First, I think we can improve antibiotic stewardship, anticipate seasonal increased antibiotic demand, and adjust prescribing patterns, which means if you know that when there will be the surge or an increase of the demand for use, you can adjust the number of the stock or macrolide stocks in your pharmacy inventory that will improve antibiotic stewardship indirectly as well. Climate response medication supply planning. As I mentioned, you can plan your macrolide supply in your pharmacy inventory or forecast the demand of the macrolide by seasonal, because in my study it proved there is the seasonal use of the macrolide across a year. And rather than just counsel patient on medication risk only, but we can counsel people with the heat waves, pollution, and also when environmental, when we make the counseling among the patient, which will enhance patient safety and make a risk prevention. And in this study, it informed antibiotic stewardship protocol and National Defense Program on antimicrobial resistance to support policy and public health decision. And in my study, I would say it's just a preliminary study that confirmed there is some seasonal use of the macrolide in the South Thailand. So it might be a foundation for future research and innovation to develop predictive model and AI-based pharmacy system for weather-informed stock management. So it might be the future research when we try to how to say, to predict what kinds of the stock that we should have in some certain months of a year. For the take-home message, medications and environment are interconnected. This statement has been confirmed by the first study and by my study. Drug use, safety, and distribution are influenced by environmental conditions. Environmental exposure plus medication equal to combined risk or benefit. Environmental factors may modify the drug effect. That's the reason when we study the environmental pharmacoepidemiology, we tend to study the interaction effects between environmental exposure and the medication that you are interested in. Environmental pharmacoepidemiology, I have to say, is the new research framework. People have a huge chance to explore environmental pharmacoepidemiology research, but if you want to explore environmental pharmacoepidemiology research, you should focus on interactions rather than isolated effects. Climate can influence antibiotics use, that confirmed by my study. And advanced models are needed, unfortunately, because of the non-linear trend between the climate factor and the outcome that we are interested. And in the future direction, I try to integrate prescription environmental factor and antimicrobial resistant data to confirm the mechanism under the pattern of the macrolide use. And I'm not quite sure some of you whether or not attend Asian Conference on Pharmacoepidemiology next month. But if some of you have a chance to attend this conference, please visit my poster in this conference, because this study has been accepted to present as a poster presentation in this conference, and in this time we can meet face to face in real in the conference next month. I hope that some of you might have a chance to attend this conference in sooner or later. Okay, that's all about my presentation, and I hope it would not make you feel a terrible headache too much. Some question, please feel free to ask in the session. Thank you very much.
Thank you very much, Dr. Tanafich, for that enlightening and inspiring presentation. And I would say that was a great and amazing study. For all distinguished guests, now we will continue to discussion or Q&A session. We are very welcome to receive so many questions, but due to time limitation, we are going to open for 2 sessions, which is 3 questions each from the participants are welcome. If you have any question, please feel free to type them in the chat box, or you may raise your hand to ask directly to Dr. Tanafich. Any question from our beloved student? Oh, there's one. For the first question, I will Miss Angel. Mrs. Angel.
Thank you, Ms. Junita. Good afternoon, Dr. Tanafich. My name is Angel. Thank you so much for your very insightful presentation. I have one question. Your study used temperature, humidity, and rainfall data from NASA and Google Cloud. I'm curious, are there other remote sensing indicator or parameter that we can collect from NASA and Google Cloud that might also influence medication use patterns supporting pharmacoepidemiology research in the future? Thank you.
Okay. If I understand correct, your question is you just want me to explain more a little bit about this kind of the data source, right?
Yes.
Okay. As I mentioned, it's really difficult to assess or to evaluate how much dose of the exposure, especially the factor, how much you expose to the sunlight, how much sunlight you expose, how much temperature you expose, right? It's really difficult. The thing that we can do in this time, that we use something so called the open and public data source, so called the NASA and the Google data. In the Google data, when you access into this data, into this website, you just key in your location. You have to know that what kind is the longitude and latitude of your location. For example, in my case, all prescription in my case occur in the university hospital, right? The university hospital is located in the Tasala district. So I assume that people who came to the hospital and receive this kind of the prescription, they also stay in Tasala district. So I find the latitude and the longitude of the Tasala district, and then I assume that okay, all of them, when they come to the hospital on the day, month, and the year, how much Celsius degree that they exposed in 2 weeks ago before they came to the hospital. So that means I access to the data set and look back into the temperature in 2 weeks before they came to the hospital, and assume that they exposed to the that biweekly temperature. So the key message before you retrieve the data, you have to know first date and month and year that you want. The second, you have to make an assumption. You have to make an assumption that people who came to the hospital the 2 weeks before they came to the hospital, they still stay in Tasala this. So that means you have to go to the location of the Tasala district in latitude and the longitude, and it will come up with the data of the temperature, humidity, and the rate and the rainfall or the precipitation by these two data sets. It's quite a little bit complicated, I have to say.
Yeah.
Yes.
Yeah, but thank you for your response.
Yes, yes.
There was a great explanation and answer from Dr. Tanavich. For Mrs. Angel, it's clear enough, right?
Yes, thank you.
Okay, we are going to move to the second question. Please, Ahmad Faisal Irawan. You can ask the question directly to Dr. Tanavich.
Okay, thank you for the occasion. Good afternoon, Dr. Tanavich.
Good afternoon, Ahmed.
And first thing first, I want to say thank you for giving us a new insight for pharmacoepidemiology approach. My question is, since your study used environmental data derived from satellite-based remote sensing, which is maybe a new method and uncommon in Indonesia.
Yes.
I'm curious, how do you evaluate or ensure the accuracy of this data? I mean, if we compare the clinical prescription data, they are usually more precise, right? The conventional method. I just want to ask, how do you manage possible discrepancies when integrating these two data sets in your research? Thank you.
Good question, Ahmed. I really love this question because you asked the same question to my PhD advisor. Well, I have to say that the ideal data set that I want to use is it should be I would say the climate data from my nation. However, it's really difficult to access to the data set. I mean, in terms of the climate data from my national data source. So in terms of the researcher, I have to say we can compromise in our ambitions to use. In terms of the accuracy from these two data sets, they use a NASA for example, the NASA satellite. It comes up with an hour of the data. So the data come to the database an hour, not by minute or not by second. So you are right. There are something so-called inaccuracy in terms of the data set. But is this the best that we can do? Is this the best that we can retrieve the data? And I have to say, whenever you deal with the model, all model is wrong, but some are useful. I have to say that when we say something about the model, I try to explain in a very detail those kind of detail is supposed to be my assumption behind the model. So yes, you are right. There are something so-called inaccurate in terms of the estimate environmental factors, but this is the best that we can do. But in terms of the discussion, yes, you can argue with that.
Okay, that was a great question from our student, right, Dr. Tanavich?
Yes,
Because
yes.
the data is took from the satellite, it's more difficult to make sure the accuracy, but it's the best we can do, right? To get the
Yes.
environmental data. Okay, we're going move to the third question from Rina.
Yes.
Yes, you can ask your question directly to Dr. Tanavich.
Okay, thank you for the opportunity. Good afternoon, Dr. Tanavich. I'm Renat
Hey,
Almudaputri from.
good afternoon.
Good afternoon. I'm Rinat Almudaputri. You can call me Rinat. I came from Jember University. We also know that Thailand and Indonesia have a similar season, like high humidity and high rainfall too, and any other various patterns, seasonal temperature like season or summer, winter, summer, like your presentation that Tasala, I think Tasala from 2021 until 2023.
Yes.
And now in my district, Jember, it's still rainy season now, and many of us get a symptom like cold, a common cold, and the other disease like a flu, like that. And my question is, and that symptom correlate with respiratory disease or infection. My question is, what other disease apart from those related to respiratory infection do you think would be suitable for analysis using this environmental pharmacoepidemiology approach, especially in our country, Indonesia?
Excuse me, could you repeat your question again because I cannot hear you well?
Oh yes, sorry.
Yeah.
My question is there any disease apart from those related to respiratory infection do you think would be suitable for analysis using an environmental pharmacoepidemiology approach, especially in our country, Indonesia?
I'm afraid that I have no idea about your country epidemiology, but yes, as I mentioned that the explanation why macrolide has been used highly in my country, especially in Tasala. First, it's because of people they were respiratory infectious disease, but they are not just only the respiratory infectious disease. They also have the comorbidities. Also, comorbidity will make their symptom even more severe comparing to people without comorbidity. That's the reason those kind of people, even though they came to the hospital with respiratory infections, but they have to also use the macrolide in my case. The reasons that we add macrolide in my study because of the comorbidity of patient, and those kind of comorbidity of patient will make their symptom even more severe than people without comorbidity. Plus, they were assumed that to have atypical bacteria, and with the atypical bacteria, sometimes is the first choice to kill atypical bacteria. That's it. That is the context of my country, but I'm not quite sure for the Indonesia. It should be the same or different.
Okay.
Yes.
But I'm so curious about in Thailand when we want to prescribe this microlide like antibiotic, is there have to using a prescription and the regulatory is very strict? Or,
Yes.
okay, that's similar with Indonesia too.
Yes.
Okay, that's all from me. Thank you for your answer, and hope
Yes,
we can meet in another time. I mean,
you're welcome. You're welcome. Really love your question.
Thank you for Dr. Tanavich and Ms. Rinat. For the first session, it's already up for 3 questions, and we will move to the second session with the 3 questions. Oh, there's 1 question from Ms. Diah Ayu. Could you please turn on your camera when you want to ask your question directly to Dr. Tanavich? Ms. Diah Ayu?
Oops.
Okay. Yes, you can ask your question directly to Dr. Tanavich, right?
I'm sorry. Okay. First of all, I would like to say thank you for Dr. Tanavich for your lecture earlier. So my question is, I'm actually curious about the mathematical models you used. Could you share how the GAM and DLNM help you better understand the connection between environmental changes and macrolith use patterns? Thank you.
Can you repeat your question again? I didn't hear you well. Sorry.
Could you share how the GAM and DLNM help you better understand the connection between environmental changes and macrolith use patterns?
I think the question asked by Mrs. Dia Ayu is about the mathematical models you use, Doctor. Could you share how the GAM and DLNM models help
Okay.
you better understand the connection between environmental change and the macrolith use patterns, like that?
Okay. Okay, for GLM, if you learn research methodology, you might think about linear regression, right? Yes. So you all independent variable has a linear relationship with the dependent variable. So that means in GLM, we treat every independent variable as the linear. However, in terms of the association between climate factors and the prescription use, as if you remember, I make a review, it never be linear association. Therefore, we cannot use the GLM in this case. We have to use something so-called GAM. GAM it stands for General Additive Model. What kinds of the additive model? It allows us to add something so-called nonlinear term into the model. So we use the GLM, but in GAM, we change from the linear term to nonlinear term in the model. That's it.
Yes. Thank you for the explanation, Doctor. For Mrs. Dia Ayu, it's clear enough?
It's clear, very clear enough. Thank you.
Okay, thank you, Doctor. Should we move to the next question in the session? Mr. Almas? Mr. Almas? Yes, you can ask your question directly to Dr. Tanavich.
Okay, thanks for excuse me. Is my voice clear enough?
Yes, it's clear enough.
Yes,
Okay.
clear enough.
Okay. Thank you, Dr. Tanafis, for your interesting explanation. And I'm Almas. I'm interested in the light effect on microbe use. And you also mentioned that there were light effect on temperature on microbe use, right?
Yes, yes.
Could you tell us more about what this delayed effect mean in practical terms for public health or prescribers' behavior, and why we must consider this?
Good question. Um, in Thai, I would say in the Thai context, in Thai context, we are concerned about something so-called One Health. I hope that you might you have familiar to the term One Health, which means that in terms of the public health, if we want to deal with the data, to deal with the problem like antimicrobial resistance, we should not combine all kinds of factors, not only the drugs or people, but we should combine environmental factor into the model of the problem solution. So in my study, I introduced that maybe climate change or climate factor is a kind of the variable that you should consider to when you think of the antimicrobial use, which finally link to the antimicrobial resistance. However, I have to say, in my study, it's just a preliminary study, so they need more evidence to confirm what is the role of the temperature or the climate factors in terms of the public health solution for the antimicrobial resistance. But at least I ignite all kinds of the policymaker and the researcher that, okay, rather than just think about restrict the number of the antimicrobial use, you might have to you might need to consider that the reason behind they use the antibiotic is not just only the disease that they had, but the thing behind the disease that patients had is about the climate change. It's about the climate factors. Hope my answer satisfy you.
Okay, for Mr. Almas, is it clear enough? The answer from Dr. Tanavich?
Okay, it's clear enough, Dr. Tanafit. It's my new it's my new perspective for because in your explanation. Thank you very much.
You're welcome.
Okay, thank you, Almas, and thank you, Dr. Tanavich. For the last question, is there any question from our beloved student? Okay. Okay. If you have any question, you feel free to ask Dr. Tanavich, yeah, because we still have one last chance, yeah, for this question, for the last question. Yeah, there's one last question from Mrs. Marista, right?
Right.
Yes.
So I'm sorry. First of all, I'm sorry, doctor. I can turn on my camera. Thank you for your lecturer before. So here I am. I want to ask a question. May I ask about the final model equation you used? Was it derived from a standard GEM framework or adjusted specifically for your dataset? And could you please explain briefly how the predicted or expected DDS were calculated from this model?
I'm afraid I don't hear you. I don't hear you. I didn't hear you well because of you have a noise while you speak.
Okay, Marista, would you please
Yeah.
to repeat again?
Yes.
Is my voice clear enough right now?
It's clear, but could you please a little louder?
Okay, is this clear enough?
I think it's clear enough for me.
It's clear enough, but you know there is a noise. There is a background noise which make it a little bit unclear. Can you type?
Yes.
Okay.
Yes.
Okay, I will wait for you.
I'm sorry
Okay.
for the trouble.
Okay. Yes. Okay, we will wait for the question typed by Marista. Doctor, I'm also curious about the can I ask you a question?
Sure. Many questions.
Okay. I'm very curious about the like effect in your mathematic models. You assume the like time is about 0 till 8 weeks. Is there any specific reason? And you pick the data bi-weekly, right, doctor? Is there any consideration or was there any particular consideration for selecting this type of like?
Yes. I have to say in reality when we try to pick what kinds of the environmental exposure, I mean we should be the climate exposure. For example, how long will you measure the exposure on that day, a day before, 2 day before, a week before, 2 week before. It depends. It depends on the how to say the etiology of disease. For example, in my case, I think that macrolide should be used for respiratory. So I think it's not just people who export to a sudden temperature and then they will become sick. They should export earlier. But how long? A day, 2 weeks before, uh, 4 weeks before, 8 weeks before, I don't know. That's the reason I have to make something so-called sensitivity analysis and see, okay, is there any effect from the 2 weeks before? How about 4 weeks before? And how about eight weeks before? Yes. And in my case, it seems that by the model, it shows that there is something so-called the lag effect from the temperature. Yes, you may write that why not? Why don't I use the one week before? In terms of the environmental epidemiology, they tend to measure the exposure in 2 weeks. I mean, in terms of the temperature, they favor to measure 2 weeks before rather than the 1 week before. Yes.
Yes, thank you for the explanation. I think one of the consideration is because of the etiology of the disease, and then any other consideration you already said that. Okay. Would you mind? Would you? Okay.
Yes.
There is a question from Marista.
Yes. She asked me about the final model
Final model.
equation. Yes. What is derived from the standard GAM framework or adjusted specifically for your data set? Oh, very tough question. Okay. I answer the first question. Basically, I have to say it's like I use the GAM framework, but the variable or covariate that I put into my model, it depends on my data set. So you might be asking me that is this a shuffling that data? A little bit shuffling the data. Yes. because we have the data on hand. So I try to use the data as much as I can. So the answer for the first question is yes. First of all, I use the GAM standard framework, but the covariates and the variables that I have made and I have added into the model, it depends on my data set. And the next one, could you please explain briefly how the predicted DDD were calculated from the model? How the predicted DDD were calculated from the model. I hope that you understand how to calculate the DDD, right? And the predicted DDD, it means that from the equation that I propose, how much DDD of the macro line would be. So it directly calculates from the equation that I use in GAM model. Yes.
Okay, thank you, Dr. Tanafis. For Mrs. Marista, is it clear enough?
Yes, it's clear enough. Thank you for the new insight. Dr. Tanafit, have a good day.
Yeah, you too.
Dr. Tanafis, it's I think we have the one last question from our coordinator bachelor program study of the pharmacist. Okay, Dr. Afifah.
Yeah, thank you very much, Miss Yunita. Thank you very much, Dr. Tanapits, for giving us a guest lecture today. So I and Miss Yunita is part of the drug utilization research in our faculty. So this is a new approach, I think, for the pharmacoepidemiology. So before we only know about the time trend analysis, but I think your study is more comprehensive. So in regard of that, I would like to ask, because Indonesia, regarding the prescription, we have a unique holiday in Indonesia. So in some months, we have very unique holiday, for example, like Idul Fitri and then Idul Adha for big holiday. And sometimes we found that our community buying some kind of drugs very high in the seasons. So using the same method, could we also predict the consumption of the drugs, special drug, usually the lipid lowering agent drugs, comparing to the holiday season? So could we also use the same method of your research to be implemented in this kind of study?
In case of the seasonality, I have to say that it's very how to say it only fits to the assumption of the factor attributable to your study. For example, if you assume that the trend it came from, for example, your culture event, your extracurricular, your activities. I don't recommend to use my model, because my model only fit on the seasonality in terms of the environmental factors rather than sociological factors.
Okay.
Yes. But in case of the GAM as the backbone, you can consider it to use the GAM, but you have to be more clear what kinds of the nature of the factors that you use. For example, in my case, I know the nature. I know the nature of the temperature, which is the association between temperature and the DDD of the macrolide is never linear, right? But in case of, so that's the reason I use a GAM, because it allow us to use nonlinear trend in the model. Plus, inside of the GAM, if you use the how to say, the smooth function, in terms of the smooth function, the assumption is very how to say, when you use smooth function, that means you have to be sure that your assumption is very quantitative rather than qualitative. Yeah. So in conclusion, I think you can try to think about the GAM. You can try to think about GAM, but maybe you have to consider the component inside the GAM. Yes.
Okay. Yeah. Thank you.
Thank you.
Okay. Thank you for Dr. Tanavich. I think the time for this session is already up. All the distinguished guests, let me give a brief summaries from speech from Dr. Tanavich Panoy. Dr. Tanavich Panoy introduced the concept of environmental pharmacoepidemiology, which examines how environmental factors such as temperature, humidity, and rainfall interact with medication use and health outcomes. The finding from his study on macrolide antibiotic prescription patterns in southern Thailand, where hospital prescription data were linked with NASA and Google climate datasets from 2021 till 2023 using generalized additive models and distribute like nonlinear models. The study revealed that warmer and more humid conditions were associated with increase of macrolide use, reflecting seasonal respiratory infection trends. Dr. Tanavich emphasized the need for integrating environmental data into pharmacoepidemiological analysis to better understand drug utilization patterns and support climate-responsive healthcare strategies. All the distinguished guests and participants, we have now reached the end of today's guest lecture session. On behalf of the Faculty of Farmasi Universitas Jember, we would like to extend our heartfelt appreciation to Dr. Tanavich Panoy for his insightful and inspiring lecture entitled An Environmental Pharmacoepidemiology Approach. Thank you very much, Dr. Tanavich, for sharing your expertise, valuable experience, and knowledge with all of us today. Your presentation has brought our understanding and provide meaningful perspective for our student and faculty members. As a token of our appreciation, we would now like to present an electronic certificate of appreciation to Dr. Tanavich Panoy for his valuable contribution as the guest lecturer in this academic session. Yes. Yes. Okay. For the operator, could you help me? For Dr. Tanavich, here's the certificate from us, the Faculty of Pharmacy of Universitas Jember. Thank you very much, Doctor.
Thank you for your certificate. Yes, and thank you for your attention, and I hope you enjoy for my presentation. Thank you.
It's really enjoyable. Of course, don't worry, Doctor. We truly hope this event will strengthen the collaboration between Walailak University and Universitas Jember, and we look forward to more academic and research cooperation in the future. Before we officially close the session, we would like to kindly invite all the participants to turn on your cameras for a documentation photo session. For the operator, can you help me to take the pictures? Okay, let's begin for the first slide. It's ready. 1, 2, 3. And for the second slide. Okay, 1, 2, 3. For the next slide. 1, 2, 3. For the next slide. Okay. 1, 2, 3. Okay. For the next slide. Okay. Okay. 1, 2, 3. Okay. Okay. I think for the last slide. Okay. 1, 2, 3. Okay. Thank you everyone for your kind participation and enthusiasm through today's lecture. We wish you all continued success and good health. With that, we officially close today's guest lecture. See you again at our next academic event. Assalamualaikum warahmatullahi wabarakatuh. Sawadee-ka.
สวัสดีครับ Thank you very much.
Yes. Thank you, Doctor.